All right, let's make sure it's recording. All right. So today we're going to talk about section 3.2, which is truth tables. Truth tables are a way for you to determine whether a compound statement is true or false. So definition of a truth table, it says that a truth table is a table that has a row for each possible combination of truth values of the individual statements that make up the compound statement. All right, so an example of your textbook uses, they come up with this compound statement. Today is Monday. There we go. Today is Monday and it is sunny outside. So that's the compound statement. Today is Monday. And it is sunny outside. I ran out of room, so we'll say it is sunny. All right, so this is an example of a compound statement. I wanted to talk about what does this part mean right here, this each possible combination of truth values. All right, so what that means is that, for example, in our statement here, we have the compound statement, today is Monday, that's one simple statement. And it is sunny, that's another simple statement. So you could have any combination of truth values for these statements. For example, these could both be true. So that's the first row of the truth table up there. So P represents the first statement, Q represents the second statement. That first row says, okay, they're both true. Right. Or you see in the second row, there's also the possibility that the second statement could be false. That would be the situation where the first part is true, the second part is false, which is represented in the second row. The third row is where the first statement is false and the second statement is true. Would y'all say it's sunny outside today? So that would be like this scenario for today. Like it's not actually Monday today. That part's false. But it is sunny. Right, and then of course the last possible combination would be where they're both false. So that's what it means by each possible combination of truth values. You can see that that combination is reflected in the last row. So those first two rows over there, those will always be given to you. So these two rows, or excuse me, those two columns, these guys are always given to you. And I just wrote this part over here just so we can refer back to the rules as we do the truth table. But this is like a good example of like what you might want to write on your index card for our next test. And then I had one more word. I wanted to tell you one more like vocabulary word, which is tautology. A tautology is a very special scenario when you fill out a truth table and your last column is all T's. So this is where your last column of the truth table is all T's. So of course T stands for true, F stands for false. So a tautology is where your last column is all T's. If you end up with your last column being all T's, that just means that the compound statement is always true. That means that the compound statement is always true. If you end up with all F's in your last column that doesn't have a special name, it just means that your compound statement is always false. Now this is pretty rare that you get a tautology. Typically you'll have a combination of T's and F's in your last column. So this is a special scenario. We end up with all T's. But I wanted to bring up this word because you have some questions in the homework that say something like, determine if the compound statement is a tautology. So you have some questions in the homework, maybe just one, that says, determine if the compound statement is a tautology. So I wanted you to know what that word meant. All right, so what we're going to do today is I'm going to go through each one of the rules individually. I'm going to tell you why they're T's or F's, and then we'll do a bunch of, we have like 4 examples, I think. And I think that after you do those 4 examples, that you will feel more confident to go in and do the homework on your own. All right, so let's talk about the rules. There's 4 rules for now. There's one more rule that we talk about in the next section. The first rule is for negations. This is the easiest rule. So I didn't even include it in the table over here because it's so simple. All right, so for a negation, we know that the definition of a negation is that it's the logical opposite of the original statement. So if the original statement is true, the negation will be false. If the original statement is false, the negation will be true. Very simple. Now let's look at the second rule. And statements. I think I mentioned to y'all last week that these are also called conjunctions. And statements are also called conjunctions. So just in case in the homework, if they say something about a conjunction, you know that that just means an and statement. All right, so I'm going to write down that compound statement that we used at the beginning of class. Today is Monday and it is sunny outside. And then we'll talk about how why the truth table rules are the way they are based on that statement. All right, so today is Monday. And it is sunny outside. All right, so the first 2 columns are just your P and Q. Of course, in this scenario, this would be P. Put a line through my Q so it doesn't look like a 9. So, first 2 columns are given to you. What I want to talk about is this last column and why these truth values are the way they are. All right, so we know that and, if you think back to like sets, when we talk about sets, remember and means they both have to be true. All right, so let's imagine that this is true and this is true. So let's imagine that today is Monday and it's true that it's also sunny outside. So the compound statement, today is Monday and it is sunny outside, that would definitely be true. So if they're both true, then the compound statement is true. All right, but let's consider the scenario where the second part is false. So today is Monday, that's true, but it's not sunny outside. So if the second part's false, then that entire compound statement would be false. Today is Monday and it is sunny outside. That cannot be true because we already know it's not sunny outside. So that's why we have an F here. All right, now let's flip them. First part's false, second part's true. You probably already get the picture. So remember, we said this is actually the case for today. Today is not Monday, Tuesday, and it is sunny outside. But the entire compound statement, today is Monday and it is sunny outside, would be false. Because they're not both true. So that's where this comes from. If they're both false, then of course, the compound statement would be entirely false. Right, so I'm going to fill in the rule over here. And the way I like to think of this rule is it's almost always false. So it's special when it's true. So it's almost always false. And it's only going to be true if they're both true. Okay, let's look at the rule for or. The rule for or is almost kind of like the opposite. It's almost always true. All right, so remember or, when we talked about sets, we said like, we're talking about P or Q. That can be P or Q or both. All right, so if we did the statement, today is Monday, or it is sunny. So remember P or Q, that means P or Q or both. So if they're both true, then of course the entire statement is true. Just like on the last one. But the difference on this one is that with or statements, all you need is for one piece to be true. That's going to make the entire statement true. So if one piece is true, it makes the entire statement true. So you can see that reflected in the next row. One piece is true, makes the entire statement true. And then if they're both false, the entire statement is false. The hardest rule is the last one, which is for implication. Oh, and I forgot to mention, or statements that have a fancy name too, they're called disjunctions. So or statements are called disjunctions. So the way I would describe this rule is it's almost always true. It's going to be a special scenario when it's false. Almost always true. It's only going to be false if they're both false. All right, so like I said, the hardest one to understand is the last rule, which is for implications. So implications have a couple of other special names. The first one is also called a conditional. So it's also called a conditional. You could also just call it an if-then statement. Sorry, I'm going to. They're also called a conditional, also called an if-then statement. The best way to think about this rule is to think of it in terms of like a promise. So it's going to be true if the promise is not broken, and false if the promise is broken. So let's pretend we have this scenario. If you give me $5, I promise to pay you back. All right, so remember, it's going to be true if the promise is not broken. It's going to be false if the promise is broken. All right, so let's consider our 4 scenarios. The first rule says both statements are true. You gave me the $5, I paid you back. No promise was broken, so we have a true. That one's easy to understand. The next one is where the first part is true, but the second part is false. So you gave me $5, but I never paid you back. So the promise was broken. So that's why you have an F here. So the promise was broken, so the compound statement is false. All right, now the last 2. Let's imagine that the first part was false. You never gave me $5, but I did give you money back. So no promise was broken. You just got an extra $5. So the compound statement ends up being true because no promise was broken. And then the last one is where they're both false. You never gave me $5. I never paid you back. No promise was broken. So the compound statement is true. Now, you don't have to remember the reasoning behind these rules. But I just wanted to explain it to you so that you're not just like blindly following these rules. Now you at least have some context for why they are the way they are. In the future, when we use these rules, we're not going to sit and think about, why is this one true? Why is this one false? We'll just go along with whatever the rule says. Okay? All right, so let's look at our first example. We'll start off with an easy one. Construct a truth table for the following compound statement. You see the first two columns are filled in for you. Can y'all read this to me? What does this say? Very good. A or not B. A or not B. So, with that said, it's important that you know all those symbols. Remember those symbols? Not, and, or, and implies. So make sure you know those symbols. A or not B. All right, so first two columns are filled in. One thing that I found really helps, and I don't know why, but it really helps if you cover up the column that you're not using. So right here, we're filling in the column not B, so we don't need to use A at all. So you can just take your little pencil or pen or whatever and just cover up this column with your pen. Can y'all tell me what I would fill in here? False. Good. Now, look at, you had 8 boxes to fill in. 4 of them are already done, and that was super easy. So even if you blank out on the test, you forget how to do a truth table, at least do the negations, because that's like half the point. So at least do the negations, even if you completely forget how to do truth table. All right, then we have A or not B. So I'm going to come over here. I'm going to make little boxes so that we can cover up the columns we're not using. I would suggest having like a couple of pencils or something laying around while you do your truth table so you can cover up the columns you're not using. It really does help. All right, so A or not B. All right, the rule for or says it's almost always true. Only going to be false if they're both false. Do you see anywhere where they're both false? The third one. So that's going to be false. What's everything else going to be? True. So do the special ones first. The rest of them, you don't even have to think about. And then we're done. So do the special ones first. When you're using those rules over there, do the special ones first. And the rest of them, you don't even have to think about it. All right, let's look at a harder one. Here we have 8 rows. Let me go ahead and put that off to the side. All right, so let me tell you why there's 8 rows this time instead of 4. Now we have 3 statements, A, B, and C. For every new statement that you add in, you get 4 more rows. So we started off, we only have 2 statements, we have 4 rows. And these 4 rows. We added a new statement, we get 4 more. All right, so if we added another statement, we would have 12 rows. So the truth table would get really big really fast. All right, so first thing we need to do is fill in the column not C. Oh, I guess I should read the entire compound statement. Y'all think about it for a second. Look at the compound statement. Think about how you would read it. A and B or not C. Very good. Okay. Oh my goodness. This kept happening yesterday. All right, there we go. Okay, so let's fill in not C. Yeah. So just the opposite of C. All right. You'll notice in your homework and in your textbook, they do the negations first every time. I don't know why they do it that way, but that is the way they do it. All right, this time we're using A and B. So I'm covering up everything except for A and B. All right, the rule for and says it's almost always false. It's almost always false. It's only going to be true if they're both true. So which ones are going to be true? First two, anywhere else? Nowhere else. So what are the rest of the rows? Yeah. So I'm going to have to think about it makes it very easy to do it this way. So I used to teach this where like, we would look at each row and say like TF, and then go over here and be like, okay, TF is F. But if you do it this way, it's much faster. All right. Last column, we need A and B, and we need not C. All right, so let's cover up that. Let's cover up C. All right, now you have to be careful here because notice their columns are out of order. This is the first part. This is the second part. So that's the first part. That's the second part. So the columns are out of order. If it really bothers you, you could add in an extra column right here and just rewrite not C. Does that make sense? So if it really bothers you and you would like the columns to be in order, you just add in another column. Or you can just be really careful and think about it in your head. Okay, this one comes first, this one comes second. All right, so here we have A and B, here, not C. Here. They're connected with an OR. Okay, so the rule for OR is it's almost always true, only false, they're both false. All right, so if you see any FFs, three of them. Okay, so this one's going to be, what is this, true or false? False, false, false. 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 Oh, yeah, that's true. All right, so how do you feel so far? You feel okay? It's a lot harder when you're by yourself, I promise. I don't know why. But if you say it in the way I'm saying it to you right now, so look at the rule, and go to your chart, say, okay, what's the rule for and? It's almost always false. So say that in your head every time. That'll make it easier. All right, so this is the last one I have on your paper. And then I added in an extra one yesterday after I printed them. Notice this is kind of a special problem. This came off of the homework, obviously. Almost the whole thing is filled in for you. It says construct a truth table for the following compound statement. This is a big one. A or not B, or A implies B. All right, so almost the whole table is filled in for you. We only have to fill in the last column, which says A or not B, or A implies B. All right, so let's cover up the ones we aren't using. That's the first two. A or not FS. All true. means that regardless of what the truth values are for A and B, this compound statement will always be true. It's a very special scenario. It does not happen very often. Okay, last one. I wanted to do one that had an implication in it. So I picked this one off of the homework. If you would like to take a second and write it down, I'll let you do that. It's a little bit hard to read, so let me see if I can make it bigger. That's about as big as I can make it. Like I said, I picked this one off the homework because I wanted you to have seen an implication problem. The last problem also had an implication, but we weren't required to fill in that row. It was already, or that column was already filled in. And you can see I wasn't thinking when I copied this over, I had already filled in the negation column. I'm still thinking about how I'm gonna test this, how it's gonna work with the online test. So I'll let you know when I think of a good idea, what the question will look like. All right, so you got 3 statements on this one, P, Q, and R. That's why you got the 8-row table. And the compound statement is not P or Q, implies R. So really not a terribly complicated compound statement compared to some of them that we've seen today. I'm sorry I'm not as enthusiastic as Dr. Zhao next door. I think I would lose my voice every day if I was that loud. I think that's stats 2. I'm not sure though, but I've never known stats 2 to be that exciting, but maybe with him it is. All right, so 3 statements. I probably wouldn't put a table this big on the test. In the past, I've done just like 4-row tables on my tests. But the concept is exactly the same. You're just doing it, you have more rows to consider. All right, so the first column that we have to fill in is not P or Q. Not P or Q. All right, so I'm gonna cover up the P column. And then I'll go in here and mark out the R column. Right now. All right, so not P, that's the first one. That's the first part. Q is the second part. All right, so the rule for OR. Rule for OR says it's almost always true. It's only false if they're both false. Do you see any FFs? Yes, third and fourth. Where else? So what's everything else? A little puzzle, but there's no way to check if you're right. All right. Cover this guy. All right, so the next one is not P or Q implies R. All right, so we need not P or Q, that's this column. We need R. Everything else we don't need. Put that up. Put the Q up. Okay, so we need not P or Q. All right, so this is the first piece. This is the one you have to be super careful on. The implication one. So anytime you're doing an implication rule, you have to be super careful, because remember, the only time it's going to be false is if your first statement is true and your second statement is false. All right, so we're looking for first to be true, second to be false, that's going to be false, everything else is true. We have a TF. So this is first, this is second, TF, so that's going to be false. Do you have any more TF?
Two more, the very bottom one, and then
Very bottom one.
the 1, 2 up.
Now, the most common mistake people will do right here is they'll say, okay, TF, that's false. Why is this one not false?
This is backwards.
Because it's backwards. Yeah, so the table's written backwards. Your book does this all the time. I don't know why. But they love to write the columns backwards. So if it helps you to add in that extra column, you could squeeze the R column in here, just copy it back down, and then they would be in the correct order. But if you can do it without rewriting the column, that's fine too. All right, so we got all the TFs. They're here, here, and here. Everything else is true. What if I asked you a question like, is this a tautology? It's not a tautology. We have a combination of T's and F's. All right. So what do y'all think? Is this okay? You think you can do this on your own? It takes practice. The good thing about truth tables is they keep coming up throughout this chapter, so we'll practice them a bunch. But if you, like, say if you put off the homework and you didn't do it for like 2 more weeks, I bet you would completely forget all of this. So go do the homework while it's fresh on your mind. And that way, you know, it sort of cements all these rules in your head. All right, let me stop the video.